Today we are going over an introduction to fractions. We're going to kick mixed numbers actually to the next time we meet. Uh, yeah, so sorry I'm having to do the video, but I hope it works for you. So what's a fraction? When a whole unit is divided into equal parts, we call the parts fractions of a whole. A fraction is written in the form a over b, or a divided by b if you would, where a and b are integers and b is not zero. Okay, because we never divide by zero. That's why we say that. If we divide by zero, it's actually called undefined, but we get into that later. So in a fraction, we call the top number the numerator. The numerator is the number of pieces we have. The number on the bottom is called the denominator. The denominator of a fraction is the number of equal pieces into which the whole unit is divided. Okay, so similar to like these pictures down here, the total number of pieces is the denominator. The amount that's shaded is the numerator. So top, bottom, numerator, denominator. Another name is rational numbers. So rational is just AKA fractions. It's like the college version of it, if you would. Okay. So if we identify the numerator and denominator, it's just top, bottom. So 5 is the numerator and 12, oops, my pen, sorry, is the denominator. Just as easy as that, top, bottom. And if we add letters into the mix or variables, it's no different. So the whole thing, 24x, is the numerator, and 27m is the denominator. That's it. Top, bottom. That's it. So if we want to write a fraction that represents all the shaded area, well, first, right, top, bottom. So the bottom, the denominator, so the numerator over denominator, it's just part over a whole. And this is a big mamma jamma. Okay, that will take you like 60% of the way through 1316, your contemporary math. Okay, part over a whole is going to be in your, let's see, your probability. It's going to be in your, a little bit of your statistics. I mean, it's just going to be in basically everything. Part over a whole, numerator, denominator. So if I have 1, 2, 3, 4, 5, 6, 7, 8 slices of our pizza, if you would, then the number that's shaded, 1, 2, 3, 4, 5. So then this would just be 5 over 8, or 5/8. Okay, 5/8 with like a TH at the end. So I want y'all to pause the video and I want you to try B, C, D on your own. Whenever you're ready, come back and play. Okay, so here we have 9, right? A 3 by 3. So the denominator is 9, and then 1, 2, 3, 4 shaded. So 4/9. Here, it really doesn't matter. This is just one whole, right? That's just one unit. It's the same thing. We'll talk about it later. 1, 1, 2, 3, 4, 5, 6. 6 over 6. Anything over itself is 1 because it implies that no matter how many pieces you have, you've taken them all. So you've taken the whole thing. You've taken the whole thing. So anything over itself, even if it's like z minus 1 over z minus 1, generally speaking, is still equal to 1. And we get into those properties on the next page. Of course, because math is hard, there are caveats. 0 over 0, whoa, wonky. Infinity over infinity, whoa, wonky. Okay, those, of course, there are caveats, exceptions to the rule. But generally 99.9% of the time, anything over itself is 1 because you have this whole I've shaded everything situation. And then D, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces. And then how many are shaded? 1, 2, 3, 4, 5. That's it. I think that's pretty, you're just counting. Easy peasy lemon squeezy, not lemon juice to the eyeball. Okay. So now rather than the visual, we just have it written out to us. A box contains 7 orange balls, 8 green balls, 4 red balls. What fraction of the box is made up of red balls? Oh, let's go with the red color then. Red balls. So there are 4 red balls. So the pieces, if I think of a fraction again as part over a whole, the part I'm interested in is the 4. The whole, the total amount of the marbles, whatever, balls in the box. 7 plus 8 plus 4. That is 4 over, let's see, 7 plus 8 is 15, plus 4 is 19. So 4/19. So 4, if there are 365 days in a year, what fraction of a year does August represent? Again, think of a fraction. It's, yes, numerator over denominator. But it's, sorry, my camera is so shaky. But it is also just part over a whole. Okay. So I know the whole 365. Now we're thinking days. Okay. So that means I need to know, well, how many days are in August? How many days are in August? Is it 31? I should know. It's just one of those things my brain doesn't remember. Yeah, 31. If on a test or something, if that's just kind of like common knowledge that might not be so common, please ask about that. That's something I would totally answer on a test. If you're like, I forgot how many days August is, be like, oh yeah, I'll tell you. Okay, stuff like that. That's quote common knowledge. If you happen to forget on a test day for whatever reason, I'm happy to answer that. That's 31 days. Here, if it were to change, so the answer is 31 over 365. But I want to make a point in that if it said like if we changed it to months, right? Well, then that would be 1 over 12 because August is 1 month over the 12 months. Does that make sense? So these are not equivalent fractions in the sense that 365 is the same as 12. Obviously, they're not. But it's the same in terms of like unit changes. So if I go from days to months, notice how the fraction changes. So whenever we're doing things in general, be aware of what the units are, okay? So especially like with mechanical things, right? If we're building something, we need the right tools. There's like what metric tools, like a wrench set, and then the standard, like United States standard. So we just need to make sure what units, what kind of measurement system we're using. So just food for thought. So 5, I want you to pause the video, try 5 on your own, and then play and come back when you're ready. So in statistics, class containing 67 students. Okay, so that's our total. So if we're thinking numerator over denominator, oops, denom, or part over a whole. Okay. Well, the whole we were just told is 67, right? The class contains 67 students. 17 math majors, 31 physics majors, and then the remaining students are engineering. What fraction of the class is made of engineering students? Well, here we have to do a little bit of like sub math, if you would. So we know that their total is 67. Subtracting the amount of math majors, subtracting the amount of physics majors. Okay. 67. Okay, so 67 minus 17. 7s cancel each other out. That's 50 minus 31. Carry the 1, that's 9. The 5 becomes a 4, so that's 19. Okay. Yeah, so this little side math right here, that's why I'm leaning towards letting y'all have 4 function calculators on the test. Because again, I don't want you to like shoot yourself in the foot just in case you accidentally mess up your subtraction. I know you can subtract, It's not what I'm like. I'm not testing you on your subtraction. I'm testing you on your fraction knowledge. That's why I'm leaning in that direction. Sorry, excuse me. But at any rate, hopefully, if y'all have questions, write them down, email them to me, ask me them in class next time we see each other. I know the videos are nice because you don't have to come to class, but also not nice because we're not in the moment and you can't ask your questions as we go. Plus, I make silly mistakes and y'all will watch me do the silly mistake and you'll yell at the screen. The screen. I'll feel bad. You feel bad. Yeah. Videos just aren't my favorite. I'd rather see your beautiful faces. But anyways, here are hair properties. So I mentioned this a little bit last time in class, but any integer, any whole number can technically be written over 1. So like 14 is also 14 over 1. Okay. Anything that has 0 in the numerator and divided by anything is 0, right? Because if I have $0 and I'll share them with you, then we all still get $0. We never, ever, ever, ever divide by 0. Okay, it's called undefined. So if you have any number divided by 0, doesn't matter what it is. But again, there's a caveat if it's like infinity divided by, well, no, even then, if it divided by 0, undefined, just blah. That's just what it is. Don't even like to think about it. It's a whole like division situation. As mentioned before, anything over itself is 1 because we've taken the whole thing, right? No matter how many pieces like a pizza might be sliced into, if I take the whole thing, I have 1 whole pizza. A negative number over a negative number is a positive. That's because this is technically division. Fractions are technically division. This is also negative a divided by negative b, which then spits out a positive, right? Because a negative times a negative is positive, a negative divided by a negative is positive. So a negative over a negative is positive. The location, if I have 1 negative, can be in front, on top, or on the bottom. Okay, sorry, I'm realizing the lighting is really crappy because my overhead light is terrible. Let's see. Better or worse? Maybe better? No, sorry. I hope it's okay. Oh, no, that's way worse. Sorry. A little autofocus on here. Maybe better, hopefully. Don't yell at me. All right, so it doesn't matter if there's 1 negative, that it just can float around. It can be in front, on top, on bottom. Doesn't matter. Same thing. So please commit these to memory. Write them on a little note card. You'll get a note card for the midterm. Yeah, if you have trouble memorizing those. Hopefully y'all can't hear my kids screaming in the background. Sorry if you can. They're mad I'm in here not with them. Okay, simplifying fractions. So simplify fractions, we're just using the properties we learned on the previous page. Okay, remember here, if I have nothing and I divide it by negative 19, well then it's still nothing. Okay. Remember anything, actually I want y'all to pause the video and do the rest on your own. I was about to get too excited. Okay, so remember anything over itself is 1. Anything can technically be written over 1, so it's just 9. Anything divided by 0 is undefined. Here, remember a negative over a negative is actually a positive. And again, dividing by 0, undefined. Okay, so check with your answers. Hopefully you got the same thing. So then we move on to proper and improper fractions. So a fraction whose numerator, so the top is less than the denominator, is called proper. Okay, a proper fraction has an absolute value between 0 and -1 because it's a fraction, right? So in terms of like our shaded areas earlier, proper means that I don't have more pieces than like my unit as a whole, okay? I don't have any more pieces that are cut into. Like for my pizza, I just have 1 pizza. So it would be proper if I don't take any more slices because I have a pizza. I have one single pizza. Okay, proper. Improper is where the numerator is greater than or equal to its denominator. Is called an improper fraction. So technically speaking, this is an improper fraction because I would just rewrite it as 1. Oops, sorry. An improper fraction has an absolute value greater than or equal to 1. So an improper fraction can also lead us to mixed numbers, which we'll talk about next time. But basically it says like you might have a pizza and a half. Okay, you have more than just the 1 unit, a pizza and a half. So if I label the fractions as proper or improper, remember that proper, your top is less than bottom. Basically, so if you look for your top less than bottom, you have proper, top less than bottom. Actually, y'all pause, do them on your own, and then come back, press play when you're done. So here the top is not less, so this is improper. Again, our top is heavier, so this is improper. Here, our top is less, our bottom's heaviest, so this is proper. That's it. Okay, so basically to be quote unquote proper, excuse me, your top is less, your bottom is heavier. Okay, to be proper, you want bottom heavy essentially. Okay. So then if we move on in the packet of notes, we're actually going to skip this page. We went over that already. Skip this page. We went over this already. Skip this little part right here. Okay, equivalent fractions. We're almost done, y'all. Just this page and a half left. So equivalent fractions. Determine if fractions are equivalent. So fractions are equivalent, basically, if I can multiply the left-hand side by a unit of 1, meaning something over itself, and get the same thing. So for example, if I have, say, 3/5, and I can do this because anything times 1 is itself, anything over itself is 1, so that's why it's a legal math move. So say this is 4/4. If I take 3/5 and I multiply it by 4/4, which is a form of 1, because remember that 3/5 times 1, anything times 1 is still itself. We are just like loopholing the system essentially. Hey, we found a little loophole. So 3 times 4 is 12, 5 times 4 is 20. So 3/5 and 12/20 are what we would call equivalent fractions, because I can multiply 3/5 by 4/4 and get 12/20, or on the other side, I could divide 12 by 4, get 3, divide 20 by 4, get 5. So if I want to determine if these are equivalent or not, we would say, okay, well, 5 times what will give me 15, 8 times what will give me 24, and like cross our fingers it's the same number. And it is. So these are equal because 5/8 times 3/3 version of 1. 5 times 3 is 15. 8 times 3 is 24. So they are equivalent. So on the other side, if we try to say, okay, 2 times 9 equals 18, but 3 times 7 equals 21. Well, 9/7 is not equal to 1, right? Anything over itself is 1. 9/7 is just that improper fraction, 9/7. So 23, those are not proper, or excuse me, those are not equivalent fractions. Those are not equivalent fractions. So if I wanted to find equivalent fractions, you would just say like, okay, if I wanted more equivalent fractions of 3/5, just do different versions of 1. Say 2/2, multiply 3/5 by 2/2, 3/3, 5/5, 7/7 to get more equivalent options. Or you could take, excuse me, 12/20ths and multiply by or divide by the same number. Remember, to get equivalence, you're just multiplying by a form of 1 by a number over itself, positive or negative, but not 0. Don't bring 0 into the equation. That's a whole different can of worms. Okay, so simplifying fractions into lowest terms. So that's basically going larger to smaller. A fraction is said to be in lowest terms reduced or simplified when the numerator and denominator share no common factors other than 1. So the common factor, again, we love 1 because it can be changed and altered into a trillion, actually infinity different versions. The fundamental principle of fractions, suppose that a number C is a common factor in the numerator and in the numerator and in the, yeah, sorry, my brain just melted. That's twice. And the denominator of a fraction. Then here, if this was A times C over B times C, you could factor out the C's and then recognize that anything over itself is 1. So then this is just A over B. Essentially, you're just dividing out a common number. Okay. Also, AKA the GC F. There we go. My brain wanted to, again, melt. The greatest common factor that we went over on the first or second day of class. Okay. But you're reducing by the greatest common factor. What is this same thing in the numerator and in the denominator, which is why we learn GCFs. If you don't get the greatest at one full swoop, that doesn't matter. You just kind of have to do it in multiple steps. So to reduce a fraction to lowest terms or simplify a fraction, you want to remove all factors common to both the numerator and denominator, GCF, which again is why we learn GCF. Last page, y'all. You're doing so good. Okay, so simplify the fraction to lowest terms. Let's see, how about I'll do this one. And then I want y'all to pause the video, and then try the others on your own. So if you want to think of it in terms of, this is 72x over 60 times x, because that's x squared means that I have two groups of x's. Well, here I have an x over x, so that can reduce out. 72, let's see. Well, 60 and 72 are both even. We could go further than that. Let's see. Where's my pen? If we do our little factor tree, so 72, 60 is 6 times 10. That's 2 times 5. This is 3 times 2. 72 is what? 9 times 8. That's 3 and 3, 4 and 2, 2 and 2. So they both have a 3, so I have a 3. They both have 4s, or a 2 and a 2. They both have 4s. So their GCF is 12. Okay, 12. So if I divide 72 by 12, let's see. Take out a 2, 72 divided by 12 is 6. 60 divided by 12 is 5x. Okay. So you don't have to go one full swoop. If you just want to reduce by 2, reduce by 2, reduce by 3, step by step, instead of going straight to the GCF, that's totally fine. But 72x over 60x squared is 6 over 5x. Okay. So you can pause the video, try it on your own. All right, so here, 28 over 48, I'm just gonna say, okay, let's divide it by 2. So that is 14. If I divide that by 2, that is 24. Now let's divide these by 2. So 14 divided by 2 is 7. 24 divided by 2 is 12. 7's prime, so we can't go any further. 15 over 24. Well, I know that a 3 can go into both of them. So let's say I divide this by 3, divide this by 3. Then 15 divided by 3 is 5. 24 divided by 3 is 8. That's 5/8. Last, I have an A over an A. There's no B in the denominator, so B lingers. I know that 16 and 12 have a 4 in common. So if I'm dividing 16 by 4, 12 by 4, the negative still hangs out because we're not doing anything with it. 16 divided by 4 is 4, so 4b. 12 divided by 4 is 3. 3 is prime, so we can't go any further. And there you go, that's how you simplify. Next, a two-year college employs 210 mathematics professors. 126 mathematics professors are employed in the South Campus of the two-year college. What fraction of the professors work at the South Campus? So think of it, right? Numerator over denominator. It is just part over a whole. So the total we employ is 210. We're told the South Campus is 126. Okay. So we could leave it as that, but since we are trying and practicing simplifying fractions, let's just keep dividing by 2, right? Let's just kind of go with ease. So if I'm dividing by 2, divide by 2, divide by 2. See, 12 divided by 2 is 6. 6 divided by 2 is 3. 2 divided by 2 is 1. 2 can't go into 1, so 2 divided by 10 is 5. 63, let's see. I know 3 can go into it. Divide by 3. Remember our divisibility rules. 1 plus 5 is 6, so I know 3 goes into it. 3 goes into 6 twice. 3 goes into 3 once. 3 can go into 10 3 times. That's a 9 with a 1 left over. So there's an invisible 15 here. 15 divided by 3 is 5. Okay, now both of these are divisible by 7. So 21 divided by 7 is 3. 35 divided by 7 is 5. So 3/5 of the mathematics professors are employed or work at the South Campus. Okay. So I want you to pause the video once I go after the instructions. Pause the video and I want you to try these on your own. The chart shows the number of movies a film company produced in 5 years. What fraction of the movies was produced in the 4th year? What fraction of the movies was produced in the 5th year? Okay. So if we think of things, as part over a whole, numerator, denominator, then the 4th year numerator, the numerator is 15. That's the numerator. What fraction of the movie was in the 5th year? 12. Again, that's the numerator. So we need the denominator, the whole. So basically, how many did they produce in total? 16 plus 19 plus 13 plus 15 plus 12. Okay, y'all are going to see I hate mental math. I can do it. I just, no fun. Okay, so 16 plus 19. Well, 6 plus 9 is 15. Carry the 1. So that is 35. 13 plus 15 is 28. And then you have plus 12. Oops. 28 plus 12. 8 plus 2 is 10. Carry the 1. So that's 40. So, whoops, excuse me. So then 35 plus 40 is 4 plus 8 is 3 plus 4, hello, is 7. So it's 75 movies total. So what number of movies were produced? Or what's the fraction? 15 over 75, 12 over 75. Okay, so I know that 5 can go both into these. So if I divide this by 5, I get 3. 75 divided by 5 is 25. 3 is prime, so we're done. I know again that both of these are divisible by 3, so I'm dividing them by 3 each. The reason why we are allowed to do this, sorry, I'm saying it so late, is that we can, anything we do to the top, we have to do to the bottom. We have to keep it balanced. So 12 divided by 3 is 4. 75 divided by 3. Oh, excuse me. Yeah, divided by 5. 75 divided by 3 is 25. 75 divided by 5, y'all probably screaming at the camera. So sorry about that. 75 divided by 5 is 15. There we go. Sorry about that. That's 3/15. That's a 15. 3/15. 75 divided by 3, there we go. That's 25. Okay, and then 4 and 25 have no common factors, so that is its lowest terms. All right, and that's it. We're going to just leave it here. We're at 30 minutes, so take the next 20 minutes or so. Take the next 15 minutes and work in your homework. That is your assignment. Have a great day.